What's up everyone? On today's lesson we'll be talking about the IEC 650. I'll be introducing you to IEC 650. IEC 650 is the international standard for defining devices within substation automation system and how they interact with one another. It enables integration of all protection, control, measurement, and monitoring function within a substation and additionally provide the means for high-speed substation protection, application interlocking, and inter-tripping. What are the key benefits of IEC 650? It could reduce the cost, engineering design, installation, commissioning, and maintenance. Reduces wiring costs since the base devices communicate using fiber or Ethernet, not copper wire. Allowing the addition of a new IED easier. What is exactly the purpose of IEC 150? It provides platform for designing, integrating, and maintaining substation equipment to do the following: doing control, automation, measurements, monitoring, recording, and config communication. Most cases we are having 4 levels of IEC 250 architecture, starting from the bottom, which is the process level, bay level, station level, enterprise level. Most of the information is just shown here on this diagram. We are having a process level. A process level is just we can say it's just a mechanism which is working, is happening on a switch gear panels, or which is located there on a yard. On a process level, we can mention devices such as circuit breakers, electronic cities, VTs, and transducers. And then on a bay level, we have IEDs. It can be ID from different vendors. It can be Siemens, SEL, Schneider, ABB, and so on. On the station level is where we do most of the controls. It's just a computer station or computer panel which is just located inside the substation. As you can see in this drawing, we have the operation station, engineering station, the gateway, and the GPS clock. And then for the enterprise level, you see here we have a control center. After the control center, there should be the panels or the computers which are located just installed on a control room, and that control room which is outside the substation, away from the substation, and that level we can call it an enterprise level. IEC 250 communication method. We have a client or server which is using MMS for communication, which is also considered as a vertical communication, and the peer-to-peer, which uses Goose, which is considered as a horizontal communication. What are the difference between the two types of communication method? On a Goose messages use the MAC layer to transfer a control dataset between IEC 650 devices in one-way transmission, which means with Goose we are using the MAC address to transfer any information from device to the other device. But for MMS messages, uses TCP or over IP protocol and operates in a client-server environment, which means for this one we are using the IP address for communication between the client and the server. The client-server communication. Client-server communication is used for acknowledged point-to-point data transmission in IEC 61850 digital substation. The station control or control center send a command to the intelligent electronic device, which is IED. It gets a communication or report back containing the status information. Here is the architecture or diagram which is demonstrating the communication between the client and server. If you see this first line, the client is sending the request. There is this thing sending the request to the server, and the server would respond to say, okay, my client, I've acknowledged your request. And then the client send again, okay, give this information, and then the server now say here's the information, and then this one will accept the information. So which means on the client server communication, it's a two-way communication, because the client requests and the server responds, so it's just a two-way communication. It goes on both sides. But with peer-to-peer communication, for peer-to-peer communication, ghost control block is used. And ghost is known as a communication method to be used between IEDs, and those eliminate the need for cables to carry out interlocks, log strip, as well as other information sent and exchanged between the rails. So in previous protocol, what was happening, if we are having two devices in one substation and we are willing this IED to communicate, we had to run the wiring, we had to run the cable from another bay to the next bay. So in this case, after the introduction of the IEC 250, since all our ID, we connect them to a network, we just connect a fiber cable or Ethernet cable to the switch, and so on. All the ID are just connected like that. There's no need for us to run any wiring now in a substation, any more wiring if we want to send a signal from the other IED to the next IED with this IEC 150, which is reducing so much cabling in our substation. And ghost is an example of a multicast or broadcast messages. One device sends out message intended for a group of devices on the network in a multicast case, and for every devices on the network in the broadcast case. So what is happening here, if we have a certain group of devices where we want to send this ghost message, then we send them in a multicast. But when we don't have a group, we want, maybe let's say for example, all the devices to get the signal, we just broadcast that signal. So with this one, it is considered, it is not a two-way communication. It is a one-way communication, since one device will just broadcast the information, plus broadcast the signal to other devices which are inside the substation, and other devices with the devices that recorded that information would just go and pick that information and pick, they will just pick that information. And then the ghost messages work in a different approach. It's assumed that the first message will not get through, will not reach the device where it was sent. Then it will always keep on retransmitting the message. It depends on the receiver to detect a duplicate. Only one traffic is needed. That was I was explaining before, to say it is a one-way communication. Where we are now, why are we moving so fast? Okay, here is the diagram which demonstrates the ghost messages. You can see here we have a sender, ghost message, then Ethernet switch, as I was explaining. So which means device. We are sitting on device, this first device here. On device X, we want to send a message to device Y and device Z. Then device X will just publish, and then the message will just sit here on the switch. Then device Y will see and say, okay, do I need this message? If you need it, you just take. If it doesn't need it, it will just stay there on a port of a switch. And this one again, I say, do I need this message? Okay, you need it, then you just take this message. But this one won't see that device X won't see whether device Y and device Z have received that message. It will just keep on publishing up until the status of the ghost message changes again. Just keep on publishing or non-stop. And then on IEC 250 we have a SCL, which is a substation configuration language. The IEC 250 standard for substation automation specifies the standardized substation configuration language to transfer device description and communication parameters among different vendors. What it exactly does, it allows vendors to specify IED capability, allow users to easily configure IEC 250 client without having point list, allow export and import of IED configuration to various apps and tools. What are SCL files? What files we actually find under the SCL? XML based files, the main are. If we say XML based file, these files are the files that you can read, and then they can be read by the machine again. Under this SCL file, we have SSD, which is a system specification description, which actually describes the entire system. If we say it disrupt the entire system, which means let's say you remember there where we were talking about let me go back a little bit to this diagram. We're talking about here is the station level. On the station level we can only find the SCD, and then outside on the enterprise level where we might have so many substation linked to that enterprise level, it's where we get that SSD. It's the example of the SSD. Okay, then the SCD, substation configuration description, describe the single substation. It's just a configuration for the whole single substation. And we have the another which is called the IED capability description. It describes the complete capability supported by the IED. So this one, when we get the IED from the manufacturer, it is having the default settings, and with that default setting, it's where you can see what the IED can actually do. So that's why I say it's a complete capability supported by the IED manufacturer. And the CID configured IED description, configuration for specific ID. After getting the ICD, then we do the configuration and send it to a relay. That configuration, it is no longer called the ICD, it is called the CID after that. And then IEC 650 information structure. The primary process object as well as the protection and control functionality is in the substation is molded into different standard logical nodes which can be grouped under the different logical devices. Under logical node, we have different data objects, and lastly are data attributes. Here is the little diagram which is showing what I'm just talking about to you. Under information structure, so say we have a physical device. The physical device, it can be just the physical relay, physical ID that you just bought to a shop, then they deliver to you. And the logical device is what you find inside the IED. That one, logical node, that object, that attributes. To show you more how this one is it working, how is it configured, I'm still going to post most of the videos where we are just playing with the software from different vendors, where I'll be showing you how to configure, how to make the actual IEC 650 to communicate. We are still gonna go on the practical activities where I'll be demonstrating a lot of this information. I'll be showing you what is exactly happening around here. Thank you. I know exactly, I know that on this slide that I was sharing with you, the information is very limited. But if you have any questions, if you want to answer any answers which is touching IEC 250, this was just a high standard summary of the IEC 61850. So if you need any information, for more information, you can contact me. This is myself, Fisom Zobe, and my number, and you can send the email on the attached email address. Then we have the discussion which is touching this IEC 61850. Please bear with us and make sure that you watch our next videos that we're still gonna share with you. This is not the last video, this is our first video which is talking about IEC 61850. We're still gonna post more videos, especially which are touching the practical activities, which I will be showing you how most of the softwares are working. If we are just sitting on site somewhere where we are, we'll be just sharing the information which might be very vital for you, to help you, because we'll be just presenting the practical using different software from different vendors. Thank you very much. Please bear with us and make sure that you watch our next videos that we're still gonna post. Thank you very much. Cheers.